Good morning, everyone. Today we are going to be doing some of the important questions in the data structures and algorithm that are actually mostly and frequently asked in some of the interviews. We'll be actually doing some step by step, and I've already figured out some of the questions which are naively asked in most of the interviews. We will actually going through all of them one by one in this particular series, and let's hope we actually reach some nice conclusions. So let's get started. Okay, so you might be asked some of the small array questions like manipulating the arrays, like rotating the array or by traversing the array and then getting up with some conclusion, getting up with some algorithm, something like that. You might be also asked with some of the dynamic programming approaches. You might be asked with the linked list approaches, right? You might be actually talk about the greatest common divisor programs, right? Because it's recursive in nature. You might be asked to write the iterative version of the same, right? And in this manner, you might be asked different questions. We'll be actually covering all of them in this particular video in detail, and let's actually get started. Okay, so we will actually start with the circular queue implementation. Now we'll actually get to know what that circular queue is, right? You might have already heard about the queue, right? Queue is actually just a data structure in which your elements are actually just placed one after another like this manner. For example, if you have a particular disk or any element, then you have another one, right? And then you have another one, right? And you are actually stacking them one after another from left to right, right? In this manner you are actually stacking them, right? Okay, so this is your whole kind of list. So this is your queue. Now what is the basic principle of a queue? Queue actually works on the principle of FIFO. FIFO, right? So it actually works on the first in first out. The element which was actually inserted first will be out first, right? For example, if you actually inserted this element first and then this and then this and then this and then this one, then you will when popping out the element, you will actually just keep out this or move out this particular element first in the first place, right? So this is what a queue likes to be. Now we have two pointers in a particular queue implementation. We have a front and then we have a rear. Front is a pointer which always points to the first element, the earliest element which was inserted, and the rear pointer actually points to a particular position where we need to insert new elements like this manner. Okay, so the rear element will actually point to the last position and the front element will point to the first position. So whenever we need to delete or whenever we need to pop out, then we'll actually pop out from the front location. Whenever we need to insert, we will actually insert from the rear location. So that's actually the basic purpose. Okay, so this is how the queue is implemented. You can actually implement a queue with a linked list. You can actually implement a queue with a stack, with the array, right? In the array, you will have the limitation of the size because you need to initialize the array to a maximum size. But in the linked list, you don't have the limitation of the size. So that's actually the basic difference between those. So you can implement the queue with both. Now the most asked question from both the versions is the linked list one because it's a bit harder to implement. So we need to actually implement a particular program which actually shows you the linked list implementation. So how can we do that? I can actually show you the basic pseudocode here only, and you can actually implement in any language you want, right? Okay, so if I consider the basic node of the queue to be something like this, right? I'm actually implementing the queue with the say linked list implementation, right? So I will be having a start node, right? Start node, and then I will be having the things like int data, right? I'm actually using a single linked list here, right? So I'm actually having a data. I will be having a next, nodes are next, which will actually point to the next link of this particular node, and then I will just close this wrap. And then what I can do is that I can actually just implement it. That's it, what you require in the particular program. So in the anti-main, right, if you're actually implementing with a C++ language, right, so your program will actually look like this manner, right? Return 0. Okay, so now what you will do is that you will actually just make one pointer, that is node star front, right? Node star front, and then node star next, or maybe rear. Okay, so you will have these two pointers, right? What you will do is that whenever you want to insert, you will actually insert at the front, right? For initially, when these two pointers are actually null initially because it doesn't contain anything, right? So these two pointers are actually just null. So you will actually need to make a function, right? For example, you have made insert, right? You are actually, or maybe push, right? Let's have these names, and then you have pop. Pop will delete, push will actually just push into the queue. So what will happen now? So push operation will actually just push towards the rear. So what it will do, right? If you have say rear, if rear equal to null, right? If you have no rear, means if you have nothing in the queue, then what you will do, you will actually just try to insert a new node into the rear itself. I mean, you will also mark it to the front, right? Means if a front equal to rear, because for the initial condition when you have nothing, then you will have this as the base condition. Then what will you do is that you will actually create a new node, right? You will actually create a new node like node star n is equal to new node, right? Something like this. And then you will actually just mark its data, like n's data is equal to what? Whatever the data is passed. So you also need to pass some of the data like anti data, right? So n data will actually become data. And then you will make rear equal to n. So in this manner, you will actually just set up the new node to this. Otherwise, if you have already some of the elements, right, both of them are actually not null, then what will you do? You will actually just append, right, the new node after the rear, and then update the particular rear position. You don't need to touch the front position. So what you will do? You will actually make rears next equal to, say, this new node, and then rear is equal to new node, right? And then I think in both the cases we are actually creating a new node, so we can actually make it outside, so you don't have the redundancy of the code. Okay, this manner. Okay, so this is how your push operation will work. Now let's go for the pop operation. Okay, so the pop operation will actually look for the front element, and it will actually try to move the front one position forward, right? That's actually how your link is actually working. Let me actually just visualize, right? So our front, right, our front is always and always there, like you have the front here, and then your rear will always and always be here, right? So what you will do is that when you want to actually insert something, you will actually insert something here, right? And you will actually point the rears next to be that element, and then you will shift the rear to be here, right? That's what you're doing. Otherwise, if you are actually inserting the first element, then your front and rear were actually null, right, initially. Now they have actually become the first element, so front and rear will actually point to this particular place, right? Yeah, this particular place. Now if you want to delete it, you will delete from this position, right, this front position. So what you will do, you will actually just push this front towards one position ahead. So you will actually do front is equal to front next, right? And then you will delete this one. You also need to delete, otherwise there will be a memory leak, right? So for the pop operation, right, if we actually see front equal to null, means nothing is there in the queue, so you will just return. Otherwise, if you have some elements, right, what you'll do, you will actually make a temp is equal to front, means you will actually just keep it in the memory. Then front equal to front next. In this manner, you will just shift the front one position ahead, and then what you'll do, you will just delete temp. That's it. If you want to delete an array, then you use this syntax, but it's not an array, it's just a particular node, so you will delete this way. So in this way, you will just pop up. You might have other peek operations, right, but that are actually basically on top of stacks, right? So this is the operation. Now what is this implementation? This is just a simple queue implementation, I must say, right? And one more thing to notice is that you must make the front and rear this way, right? You must make the pointers of the front and rear this way, so that they are global and they are accessible to every other function. So this is actually the implementation of say the queue, right? You have not implemented the circular queue, you have just implemented a simple queue. How you can just call the functions? You can just say now what you can do is that these all can be initialized in this manner like this. Otherwise you need to pass the front and the rear to the function itself. So what you'll do is that you will call the push operation like that, right? And it will just push up, right? And then you can also call the pop operation, which is like this, which doesn't take any data because you don't need any data, right? So you can just delete that, and otherwise they will be again set to front and rear equal to null. Now this is actually not efficient, right? Because sometimes, right, for the array implementation, let's see, For the array implementation, you see, if you are having an array, right, and you are just implementing this particular queue operations, right, then you actually can see that you have this array, right, and these are the elements, right. So for example, what you are doing, you are just deleting the stuff from here, and you will actually just shift here. So you will actually move one position forward, right, and in this way you can also move there and there, right, and your rear might be somewhat here, right. Now what happens, you have no more spaces in the array, so your space gets wasted. You still have empty spaces here, but you can't fill the things here, right. That's where the particular circular queue actually comes into existence. So what a circular queue will do, circular queue will actually allow you to insert at this position after this position. So once you have just filled up your whole array, you will actually just move towards this position and start inserting, right? Start inserting the things up until your front actually comes just behind the rear. For example, you have the rear here, right? Means if you have, say, front here, right? Suppose you have started inserting at these positions also, right. These were empty and these were also filled now because you haven't started inserting here. Rear is actually sitting here, right, and the front which was empty is actually somewhere here, right. So after inserting, rear will actually start moving here, and then it will actually keep coming here, right, at this position, and then it will come here, and then it will come here, right, because it was a front location, right. So now you can see, right, that rear has came behind front, right. So front will be in front of that rear. So your condition for the queue full would be that front is equal to rear plus 1, right. Rear plus 1 mod of this circular queue size will be actually equal to front. That's it. So when this condition is actually met, then it means that your queue is full and you can't fill up more of the elements, right. So that's actually the basic implementation. If you want to actually implement this queue with the, say, array implementation, so what you need to change. Till now we have just implemented a simple queue, not a circular queue. So with the array implement, why I'm actually showing you the simpler version, because it will be easier to make it and to convert it to a circular queue after you have implemented it in the a normal simple queue. So with the array implementation, we can see that what you will do is that you will have an array. Basically, for example, you will have empty array, right, and like 10, right. So in the empty main only we will actually just make it. We don't need to provide another data structure for it. And then you will just make the int variables like front equal to rear, front and the rear, front equal to -1, and then the rear equal to -1, right, in this manner. And then what you'll do is that, because you have nothing, and then you can also name it q. Okay, so what you'll do now, you will make a function, right. You will make a function of or what you can do is that make these things global so that you can access from the global area. So you can actually make a function push, and then you will have empty data, something like this, right. And then you have void, then you have pop will not require any data, right. And then what you will do is that in the push data, what you'll do is that if front, well, -1 will also be incremented to 1 only, right. But if front means if nothing was actually inserted, right, and rear means nothing was there, your queue is empty, then you will actually mark front is equal to rear is equal to 0, and then you will just make queues front portion or rear. Now rear you can just choose any because both are 0, then we can actually set to data, right. Else, now you will actually check for the fill up condition. This was for the empty condition, now we'll actually check for the fill up condition. So the fill condition will be when it's not a circular queue, right. Just remember. So fill condition will be when your just rear actually reaches the end, right? Your rear is actually equal to the size. So I can say rear equal to 9, right? Means if it actually reaches a state of 9, then I can say the cout, or I can make it a variable like s and the size, right? int s is equal to 10, right? So if the rear is actually equal to size minus 1, then we can say q is full or q overflow, something like that, and then return basically. Otherwise, what you can do here, you can also supply s so that it will initialize accordingly. In the other versions, I don't think it's actually allowed, but now it's allowed. Okay. So otherwise, you can just increment the rear plus plus, right? And q rear is equal to theta. That's it. Now coming to the pop operations. Say if we have to pop something. Firstly, we will actually need to see that whether there is something or not. So front equal to -1 means there is nothing. -1, then it means that there is nothing. So we can say q underflow. That's it, right? And then you can just return. Otherwise, if you have something in your queue, then as I have actually already explained, the queue will be actually deleted from the front, right? So what you will do, you will actually try to delete from the front place. So what is that? How do you delete? Deleting is just shifting your front a bit up a position ahead so that it is not accessible, right? And how will you print? Yeah, we have actually not made the functions for traversing. So in the let's actually complete this one only. Okay, so pop. So what you will do? Otherwise, you will actually need to see that whether your queue is actually containing something, because you see, well, if the front is actually equal to -1, rear 1, there was nothing was actually inserted. But if you will also need to see for a condition when the front is actually reaching to the end, so that you can just shift the front and the rear to the -1 position, so that they can all again be initialized from the 0 itself. So we will see that else if the front equal to size -1 means if it was at the last position you are deleting it. So what you will do, you can't actually move it forward. What I'm saying is that if your front is actually at this position, right, and then you want to delete it, means you want to shift your front a bit position ahead. So what will happen, you can't actually go further because there is no any element. So what you will do is that you will actually make the front and the rear was here also, front is here also, means you are actually at the last position. What you will do, right, or you can actually instead say that if front equal to rear, means if the front is actually came to the rear position, means wherever we had the particular last element, their front has actually came. So position is something like this. So what you will do is that you will just make both of the elements to be -1, means your queue is not containing nothing. So let's say front equal to rear equal to -1, something like this, right? Else it's the normal case, you are just deleting some intermediate element. So what will happen, yeah, so in this particular case what will happen is that you will just increment front, something like this, front plus plus, and then q front equal to, oh okay, sorry, front plus plus is the necessary condition, right? Means you are just moving the front position ahead. Now these two pointers will actually come into existence when you are actually having some display function, right? You are actually just trying to display the queue, right? So display function will just simply run a for loop, right? For int I is equal to front, I is less than equal to rear, I plus plus, and then cout space, and then choose I portion, and that's it. So your display function actually work in this way, right? From front you are actually moving till rear, and then plus plus. Basically for the linkless implementation of the queue, what will you run? So you will have a function right? Void display, and then in this particular place you will actually have no star temp is equal to, right? You will have say front, because from q is from front to rear, right? So uh, while you don't reach the end, right? Okay, so while temp, or if it's a single linked list, right, then we can actually say that while temp is not equal to null. That's it. This will also print all of the things, right? Because rear will be there, right? And you will have the well, these functions are actually not required in the queue implementation, right? Because these functions can be just used for debugging, right? And not for anything, because queue is not any array, right? You are just maintaining the pop and the push operations. Basically, you will have the access to only one element at a time, right? Whether from the start or from the end. If it's actually a stack, you will have the element of the end to be in hold. If you are using a queue, you will have the hold of the front element, right? You will actually not be able to look at all of the elements, but yes, for the debugging purposes and how the queue is actually working, you can actually make a function like this, right? You're not allowed to do this. Okay, so we can do this. We can just do scout temp data, something like this, right? And then it will actually just shift temp is equal to temp next, something like this. But Q will actually not allow this all operation. You can just use it personally for your own purposes. Okay. Okay, so that's it. That's for the queue implementation. Yeah. Now this was only singly linked list implementation and add implementation of a simple queue, right? Linear queue, and we are not having any circular queue. We have more kind of queues like priority queue. We have a circular queue also, right? So what can we do else? We can also try to implement a circular queue, right? So circular queue, if I actually take a new sheet, right? Circular queue is something like this, that you are actually maintaining a particular array, right? You're actually just maintaining a particular array, and you are just starting from a particular position that's actually 0. Now this array is not circular, right? But you are just making it circular. You are just visualizing it as a circular array. So you have a singly linear array, and then you have from position 0 to maybe position 9 if you have say 10 size array, and the array size is already fixed, as you know. So 9 position will actually be here, right? And then you will actually start, you will keep your front here and rear here, right? So you will have your front here, and then you will have your rear here. Okay, so what you will do is that you will actually start from this position and keep on incrementing the rear until you reach yourself. That's actually your circular queue, right? Or you can see that whether the front is actually in front of you, right? Whether you are actually trying to insert something and the front is actually in front of you. So that's actually the place of the overflow condition. And what is the empty condition? When your say front has actually came to rear, means it is the final position and you have also deleted that, then it's actually the empty condition. So empty and the full condition for the queue are really important, which you actually must notice, right? So let's actually try writing the code of this circular queue implementation. For the linked list implementation, right? For the linked list implementation, we have this, right? So we can try circular queue now. Okay, so what you will do is that you will have an again the operations of enqueue, right? Enqueuec. Let's make it enqueuec, right? So now you will actually try to enqueue in this particular queue, right? Okay, so what you need to check first, see for the initial condition, right? You will have the front equal to rear equal to -1, right? For example, it was linked list, right? So they will be actually null, right? Now what you will say, as you know, the linked list doesn't contain any size limit, so you know you have nothing, means for the linked list implementation you will have nothing, right? you don't have anything in the start. But as you actually keep on going, you will actually increase the size of the queue, right? You will actually increase the size of this particular linked list dynamically according to the numbers, right? And you will actually just keep on going accordingly. Okay, so you will have nothing in the start, right? So you want to unqueue something, so you will check, right? You will check if front equal to rear equal to none, means if this is the condition, right? Then you can say that enqueue means you already want to insert some new node. So node star n is equal to new node, and then n data is equal to data, something like this, right? And then int data, something like this, right? And then we will make front equal to rear equal to n, right? See, this is a comparison operator, right? And this is a assignment operator. This actually goes from right to left, right? This will be first assigned to rear, and then it will be assigned to front. You don't need to write 2 steps, you can actually do it in 1 step only. Okay, so now int data, then you have nodes, so n is equal to new node and data is equal to data. Okay, so if you have something in the queue already, right? Remember, it's a circular queue, it's not a normal queue, right? You will have the list implementation, right? If you are just making a new node, right, you will have the next pointer of it currently pointing to null, right, initially. But see, if there was nothing, you are just making the front and the rear equal to null, and then you also need to make the ends next. This is a crucial point. Ends next is equal to n itself. See, you will have this condition, ends next is equal to n. Basically that you are just pointing towards yourself. See, if there's a single node like this, right, if this is a single node, then its next will actually point to itself. Initially you will have the front, and then you will have the rear. Here only front and the rear, like this, right? And it will have some data like say 10. So this is a basic point to guess. Now what will happen if you want to insert a new node, right? You want to insert something new node, right? So you will have one node, and then you will have the next node. As it is a circular queue, so its next will actually point to this, and its next will actually point to this. So basically your first element was actually this one, so front will actually be still here, then your rear will be actually there, but the rear's next will actually point to this element. So you will actually break this next thing, means the front next, right, means the rear next will now point to the new node, and the new node's next will actually point to the front. This is how the enqueue operation will actually keep on going. So let's actually look at the code. If there was some other element already, so what will happen is that you will actually make, if there was some element, right? So if there was some element, then you will actually make the rear's next equal to the new node, basically, and the new node's next will actually point to front, right? That's the logic. Okay, so that's also fixed. And there is no overflow condition in the case of links. Otherwise, other than you have the memory overflow problem, that you are exceeding the memory of the computer. Until then, you are not having any problems, right? So ends next will actually be front. Okay, so rear next will actually become to n, and ends next will be actually to front. So this is how your circular queue will actually keep on going, and yeah, this will work. If you wanna just delete, right, the delete is actually have something like this, right? You will actually not supply data, dq. Okay, nq and dq are the actual names. You can just replace push and pop for this, right? These are just for the basic type name pseudocode, right? In the actual implementation, you are supposed to name that this way, so the other person can actually realize that these are the queue operations. Okay, so dq operation, right, a dequeue operation just actually dequeues the element from the queue. Now what will happen, right? If you have say only one element, this case, right, if you have only one element, right, then what will happen is that you will just dequeue it, means you will just remove this particular memory, and then you will actually point the front and rear to null. If you have two elements, from where you are supposed to dequeue, right? So you're just supposed to dequeue from the front itself, right? So you will just remove this element, you will actually move the front one position ahead, means to the next position, right, basically, right? And then you will also you will also make the rear's next again to the updated position, because rear's next was actually pointing to the previous location, right? And that's deleted now. So these are the cases. If you have nothing, you will just return. So let's check for the underflow condition. So if front equal to rear equal to none, right? This manner. So what you will do is that you have nothing, so you will just return. Else, what you will do is that you will check if, else if, right? Front, or you can say rear next rear's next position is equal to rear. So basically you are just pointing towards yourself and you have only one element in the list. So what you'll do is that delete rear, right? And then you will actually set front equal to rear equal to none, because we have deleted the only element. Otherwise you will check. Otherwise you don't need to check, because these are the rest of the cases. So what you'll do is that you will have the node star trash equal to front. So basically you will have the whole of the front. Then you will actually do what? Front equal to front's next, right? And then you will actually move the rear's next equal to, what you will do, rear's next will be actually equal to new front. And then what you'll do is delete trash. Basically this way you will actually just secure this particular queue, right? So you have done it, right? So this is the DQ operations. You will have the NQ and the DQ operations basically, right? NQ will actually get to the list and DQ will actually give you, right, the particular thing. Okay. So it will delete the elements from the top, right, from the top of the queue. So basically you might also want to get the particular hold of those elements, right? So if there is nothing, you will have nothing, right? Maybe you can just return -1 as the trigger to say that there is nothing. If you have say only one element, then what you can actually do is that you can just keep the hold into, say, yeah, anti data will be actually equal to, say, rears data. After setting to null, you can just return data, right? That way. Otherwise here also you can actually just have anti data is equal to trash, sorry, front data, and then what we'll do is that we'll just return data this way. Okay, so this is your thing. So this is a TQ operation. Okay, so this is how it will work. Okay, so one more thing is that you want to traverse your queue, right? For the debugging purposes, you might want to traverse your queue, right, implementation. So what you can do is that you can basically just make a particular function, right, void traverse. Okay, so what you'll do, you will have nothing, right, as the head, because we have already made the head in the front and the rear to be global. So what we can do is that if there is nothing, we will again check front equal to rear equal to none. Means there is nothing to traverse, and you can just return. Else you can just say node star front temp basically equal to front. So you will actually traverse from front to rear, and then while temp. Okay, so you will actually use a do while loop, right, because you need to do once, then you have while temp doesn't becomes a front again, not equal to front, right? Now we'll see, okay, what is this happening? Front is temp is already front, or it will actually end in one. But now here in this do while loop, you will have temp is equal to temps next. So as it is a circular queue, it will actually round about after a particular point of time. After going from rear, it will again become front. So if doing these, so the temps becomes so front end, you will just end up right, and in between the loop you can just print the temps data. So this is what you will actually try to do. Temp is equal to front, right? Do see how temps data, temp is equal to temps next, while temp is not equal to front. So this is actually your traverse, right? Traverse function will do. You can call this from the main function only, but yes, that will just be a simple name call. Okay, in the array implementation, how you will actually just implement this all stuff. This was actually a linked list based implementation. How we'll actually do in array implementation. Let's see. We actually make our size of 10. We have a queue with a size of 10 as right, and we have front and the rear initialized to -1. Let's see how can we actually do. Okay, so what you'll do is that you want to insert right enqueue circular array, and then we have the data. Basically, want to insert the data. Then let's see what can we do. So you have array, right? So first you will actually check for the front is equal to rear equal to -1, right? Basically both of them are actually -1, then it means that you have nothing. You don't need to actually take stress of anything. Then we'll actually take front plus plus and then rear, or you can just simply say front equal to rear equal to 0, right, at the first position. And then you will actually insert queues rear equal to data. There is nothing to worry about in the initial case because this is actually an array, but for the rest of the cases you actually need to worry, right? See, if you want to now insert, right, and the rear has actually reached the size -1, right? The rear has actually reached the size -1. Basically you will see this condition, right, that whether say you are actually at this place, right? After inserting, the rear has actually came to this particular positions, and then what will you do? You will actually just see whether front is actually greater than 0, and you have still the things left, right? So let's see. It will actually come to this particular position. Rear actually will become 0, and then you will just insert there, right? So let's do it. If the rear is equal to size -1, right? Okay, if this is the particular case, and you will see, right, and you will see that the front is actually greater than 0. After doing some of the operations, the front is actually become greater than 0, not 0. Then what you can do is that rear will actually become 0, right? And then you can just place the element towards rear is equal to data, something like this, right? Else you will see, in the else case, you will have a look that whether the queue is full or not. Now the condition comes, right? You are so it might be another case, right? Let's actually understand this is the complex one. So you have two elements right here in the middle, right? After inserting, after the rear actually has came here, rear is actually incremented and enqueuing and enqueuing, and it has actually came at this particular position, right? And then your front is actually sitting up at here, means already some element is actually at there, and that's the first element which was actually inserted in this queue. Your rear has actually came here, so position ahead is actually the front. So you will say that queue is already full. You can't actually fill more of the elements. So what you can see that else if rear plus 1 is equal to front, right? Then what you will do, you will actually just say overflow, right? Queue overflow, and then you will actually just say return, because you don't want to insert queue is overflow. Else is the sum of the name case, then you can just read plus plus, and then you can just insert the element. So this is a bit complex, right? One more thing to consider is that these two logics you are seeing here, right? The rear is actually at the last and the front is actually greater than 0. And the another condition is that the rear plus 1 is equal to front, right? These two conditions can be combined into one particular condition, right? In both the cases, this was the case when you were checking the front to be actually greater than 0, right? Otherwise, what you can do is actually you can actually again write this particular function in an optimized manner. For example, let me just copy this up, right, optimize one. So if nothing is there, right, then you can just make the front equal to rear equal to data. Otherwise, what you can do is that you can actually check for the overflow condition directly. So what you will do is that else if rear plus 1 and then combine here, right, and mod size is equal to front. So you see, we have combined both of the steps. If going one step forward and coming to 0 will be actually equal to front, then it means that cout overflow, right, and then you will just return. Else if there is no overflow, this condition will itself check for the overflow condition. Otherwise, what you will do is that rear is equal to rear plus 1, then you will just do mod s, and then q's rear portion will actually be data. Now you don't need these two conditions, right? You don't need these three conditions. You have already done into these two conditions. This is the optimized version, right? Now you already know that what mod operation does. If you are actually overflowing from the queue sides, it will actually come to 0. It will keep on doing something like that, right? Yeah. Let's actually write the deque in the circular queue array implementation function. So let's have the deque circular queue array, right? So let's see. If front equal to rear equal to not, oh sorry, minus 1. If there is nothing, then you can just say cout underflow. You can't delete. Okay. Else, what you can do is that if this is not the case, then you know that some element is there, right? So you need to check. You are actually needing to check. So let's see. So you will try to delete from the front location, right, and not from the rear location. So else you can check else what will the possible case. You might be just simply doing the front plus plus, right, basically because you are just removing the excess of this particular one, right? And deque operation generally also gives you element because you are dequeuing from the front location. So you can just make the return type to integer and then just return of that particular one. So your data was actually int data equal to say queues front, and then you might be also just returning data, right? So we need to look for the edge cases. So if it's a circular queue, right, you are actually just trying to delete up, right? You are just trying to delete up. So let's see. This is your sum position. So you are actually just having this location, right? You're actually looking at this location and you have the rear to, but there is some element ahead, right? There is some element ahead, and rear might be also behind you because rear might have came just inserting this way, right? So you need to make sure that your element there is some element, right? You need to make sure that there is some element. So you need to check whether you and the rear are actually at the same position, right? So we need to check that. Front equal to rear, right? Then and they are actually not equal to minus 1, right? That's why it is actually coming to this condition. Then what you will do is that anti-data will be actually front data. Then what you'll do is that front equal to rear equal 0. Okay, this way. Otherwise, you will check. if at some particular point they will actually be becomes equal, means they have actually, the front has actually came exactly to the rear location, then they will be initially reinitialized to say -1, not 0 exactly. They will be actually initialized to -1, means queue is empty. Otherwise what you will do is that, front will be equal to front plus 1, and then mod s. That's it. Then you have the int data is equal to queues front, and then you have to return data. Okay, so we have the data is equal to queues front, the front is equal to front plus 1 mod s, and then we have return data. So in this particular case, front will be actually shift one position ahead, and then we will just return the data, and that's it. We'll be actually having our data. So dequeue in the circle array will be actually like this only, right? So I think we have done all the cases, linked list, and the array implementation of the circular queue, right? And we have seen at the cases, right? And yeah, we can also use the traverse function here. We can actually build, right, void traverse circular queue array, right? And then what we'll do is that we'll traverse from front to rear, right? We don't have this, as I've already said. It's just for debugging purposes. So for, let's see, I will have int t is equal to maybe front, right, wherever the front was, and then while, let's have do while though, while traverse will be also returning if we have front equal to rear equal to -1, then we'll just return, means no elements to show, otherwise we'll have here. So while condition will actually say that while t is not equal to rear, something like this, right? And then what we'll do is that cout choose t portion, right? And the t will be equal to t plus 1 mod s, basically, because if you are actually using some queue, then this is actually necessary, because it will circle because you are actually traversing this way, like this, and you will again shift from this. So it might be the condition that your front is actually here, right? So we'll actually have front to rear, something like this. Okay, so this is your traverse function. So these are the function you can also run in the compilers, right? But that was for the name implementation and understanding purposes that we have actually done this much, right? So this was for today's video. Thank you so much for watching. Bye bye, take care.